Well, guys, we're getting to the tough stuff. We're going to be okay, though, because we have a lot of time and a lot of support. We are on Chapter 3, Lesson 6, and we are problem solving using charts. So we're going to learn how to build these charts. So these charts are going to be super helpful for Algebra 1 and Algebra 2. And you're probably going to use them a lot for math. Our essential question is, can you organize the facts of a problem into a chart? Our first question says one board is 4 inches wide and 8 inches longer than a board 2 inches wide. Well, let's talk about the things we know. One board, I'll just call that the first board, is 4 inches wide. So I'm going to put the number 4 in for the width. And 8 inches longer than another board. So I'm going to call that x plus 8, knowing that the x has to be another board. But what do we know about the other board? The other board is 2 inches wide. So I'm going to put the number 2 here for the second board, because the second board I'm highlighting in purple. But I don't know the length of it, but I do know that the other board, the first board, was 8 inches longer than it. So if it's called x plus 8, I'm just going to call this one x. Now, this chart was provided for you, but sometimes you're going to have to provide your own chart. So things that you'll be putting into a chart, distance equals rate times time. Sometimes you'll be putting in money. Remember, the total value of money is equal to the value times the number of coins. So if I have 5 quarters, the value would be 25. 25 times 5 would be $1.25. Other things that you'll see is like pounds and money in regards to pounds. So let's keep going. Let's see what this next question is bringing us. Jess bought some boxes of lemonade at 70 cents per box. He bought 8 fewer boxes of punch at 60 cents per box. We're not solving anything here. We're just starting to learn how to set these up. So the first thing I know, let's highlight. We bought lemonade at 70 cents per box. So I'm going to put under lemonade 70 cents per box. Now I dropped the decimals. So if I drop the decimals on this, I have to drop the decimals on everything. We don't know how much lemonade he bought. So I'm going to call that X. That's lemonade. Now, the next thing says he bought, sorry, I meant to highlight. He bought 8 fewer boxes at 60 cents. 8 fewer boxes. Well, if he bought X boxes of lemonade, my punch is going to be X minus 8. And this was at 60 cents, so if I drop the decimals, I'm going to drop the decimals completely. Now, the total column is what we use, and I'll always draw that squiggly line. Because remember, we have to multiply. So I know that when I take the number of boxes times the number of cents per box, this is what we're actually going to deal with. So we always deal with the total column. Now in this case, I didn't show the parentheses, but I do have to take 60 and multiply it by all of x minus 8. And some of you will distribute that when you solve. You definitely have to distribute that to be 60x minus 480. All right, so now we're going to do one where we have to solve it. Carrie has 40 more nickels than Joan. Let's talk about what we know already. We know we're working with nickels. Nickels are 5 cents, or we could just cancel that and not make it decimals and just call it 5 cents. Well, we're also working with dimes. We know dimes are worth 10 cents. They both have the same amount of money. How many coins does each girl have? Well, we have Carrie and Joan. So I'm going to write that over here. We have Carrie and Joan, and we know that Carrie has 40 more nickels than Joan. Then Joan has dimes. So if I called Joan J, and I called Carrie 40 plus J, or J plus 40, because she has 40 more nickels than Joan has dimes. So I'm going to write Carrie has 5 cents, Joan has 10. Now, let's go ahead and make this into a chart. I didn't have this chart built. So the first thing we're going to do is draw a chart. Really don't need all that space, so I'm going to erase. And I know that the number of coins times the value of a coin gives us the total. How convenient that this is our total. And this works out pretty well. So the number of coins that Carrie has is 40 plus J. Sorry, I make a weird J. I'll try to make it not so weird. And Joan, so this is Carrie. This is Joan. Joan has J. The value of Carrie's coins, well, she only has nickels, so they're 5 cents. Joan has dimes, so those are 10 cents. And if I multiply these together, don't forget your parentheses. Now we can make an equation. So remember, we will always work with the total boxes. So this total box is what we're going to work with. And we're going to write an equation from here. It said that Carrie, the one part of it said they both have the same amount of money. So there's a lot of things we could do. We can take these and add them. We can take these and subtract them. Or sometimes we take them and we make them equal. In this case, Carrie and Joan have the same amount of money. So I'm going to take 5 times 40 plus J and make that equal to 10J. And that's the equation we're working with, because we're just going to take these two total columns and make them equal, because it says they have the same amount of money. Let's distribute. 5 times 40 is 200, plus 5J equals 10J. When I subtract 5J to each side, I get 200 is equal to 5J. And it looks like Joan has 40, divide by 5. So Joan has 40, what did she have? She had 40 dimes. Well, let's go back to our chart. If Joan has 40 dimes, well, Carrie has 40 plus 40, which is equal to 80 nickels. And you would want to answer it like that.